Hello, we are in Chapter 6, Section 6.2, the quadratic formula. In this video, we are going to learn the quadratic formula. That gives us the solutions of the quadratic equation in the general form ax squared plus bx plus c equals 0. Now that form is very important because we need to have 0 isolated and the trinomial on the other side to be written in simplified form in descending powers of the variable to identify the coefficients a, b, and c. A by the second power of the variable, b by the first power of the variable, and c the constant term. Once we have that general form, we identify a, b, and c, then the solutions are of the following form. X equals the fraction with the numerator of minus b, then plus or minus the square root of the quantity b squared minus 4ac, and that's all over 2a. You might be familiar with some musical ways of remembering the quadratic formula. My favorite is minus b plus or minus the square root of b squared minus 4ac all over 2a. So that's a way to remember the quadratic formula that gives us the solutions to every quadratic equation. So let's play around with that. Let's solve this example quadratic equation. X squared minus 2 equals negative 4x. As I said earlier, first thing we need to do is to write it in that form ax squared plus bx plus c equals 0. So we need to isolate 0. So we will add 4x to both sides in here. And make sure we write the left-hand side in descending powers of the variable. So we're going to have x squared plus 4x minus 2 equals 0. Coefficients a, b, and c come with signs because in this general form we have pluses. And therefore we want to perceive it as 1 times x squared plus 4 times x and plus the negative 2 equals 0. That gives us a, the coefficient by x squared in this case, to be 1, b, the coefficient by the first power of the variable, in our case x, to be 4, and c, the constant term, to be negative 2. So with a, b, and c already identified, we just plug them into our quadratic formula to get the solutions. X equals that big fraction with minus b to start with, and since b is 4, minus b is negative 4, then plus or minus big square root of b squared, that means 4 squared in our case, minus 4 times a times c. So 4 times our a of 1 and times c, which is negative 2. We'll have to be very careful with the signs. This is all over 2 times that leading coefficient a. So in our case, 2 times 1. From that point on, it's just a matter of simplifying that and making sure that our final answer is a simplified radical expression. So we're going to have negative 4 plus or minus, then 4 squared is 16. 4 times 1 times negative 2 is really plus 8. And that's under the square root here. All over 2, which is 2 times 1. So negative 4 plus or minus 16 plus 8 is 24, the square root of 24, over 2. That is negative 4 plus or minus. Now, simplified radical. This is a square root, so we're looking for perfect square factors. And the largest perfect square factor of 24 appears to be 4, which is 2 squared. So it's the square root of 2 squared times 6 all over 2 still. So after kicking out that base of 2, since we have a match between the index of 2 for the square root and the exponent here in that exponential, we're going to have -4 plus or minus the 2 multiplied by the square root of whatever is left, which is 6 in our case. The square root of 6 all over 2. Now we acknowledge that in the numerator we have a common factor of 2 that will simplify with that denominator. So we keep going here. We're going to have 2 times -2 plus or minus the square root of 6 all over 2. And now the 2's between the numerator and denominator as common factors can be divided out, leaving us with just 1, and therefore the two solutions are just -2 plus and minus the square root of 6. So again, remember we have 2 of them. One of them is x equals -2 plus the square root of 6. The other one is x equals -2 minus the square root of 6, and it's always or between them. And that's an example of using our quadratic formula.